Hello everyone. Today we are going to study the last unit of the strength of materials, that is columns. So here we'll be studying the different types of columns, what this column means. Okay, we'll first understand what is column, okay, what type of member it is. Then we'll be finding out the equations to calculate the um, column load at which it fails, which are the different types of columns, what are its requirements, what are the assumptions done in while the calculating the or deriving the equations for the column calculations of the loadings. Okay, so all this we are going to study in this unit. So what is a column? Basically, it is a column is a structural member, okay, where a compressive load is applied along its axis. Okay, what is column? Column is a vertical structural member over which a compressive or axial load is applied. Axial means what? At the center of gravity, along its center of gravity, or along its center, or CG, will be applying the load. Right, at that point will be applying the load. At that point, when you apply, that load is called as axial load. On a vertical structural member, okay, when we apply a compressive, remember it should be compressive axial load, that type of member is called as column. That type of member is called as column. Okay, so here column is, or a strut is a member of a structure which is subjected to axial compressive load. So here one more is term is there, that is strut. Okay, if it is not been mentioned whether it is vertical or inclined or horizontal, then it becomes either strut or either column. If it is mentioned that it's a vertical member, then it is a column. If the member is horizontal or the inclined, then it becomes strut. Strut is also a will be, it is the same as that of column, but the positioning of that member is inclined. Okay, the positioning or the placement is inclined, and it will be the loading will be axial. Compressive axial load only will be applied over it. Okay, that is the difference here between the columns and strut. The load will be applied at the axis. Okay, same way the load will be applied here like this in the compressive way. Okay, this is column, right? This is column, and this is what? Strut. These are been seen in trusses. In trusses you will be able to see the struts. Columns you will see in the residential RCC frame structures. You will see the columns, right? So this is what is a column, and there are two types in in the members, that is vertical member or inclined or horizontal member. So horizontal and inclined members are called as struts, and vertical member is called as columns. So in column we don't have uh, we don't have flexural bending. Whenever there is a bending and shear, that type of loading is called flexural loading or flexural bending. Okay, and here there is not no shear, here there is no bending. There is a bending, it is called with a different name, so we'll try to come to that. Okay, when a column is subjected, okay, to some compressive load, okay, then it induces compressive stress, and when you apply the compressive load at a point where the column will crush, right? We are trying to compress the uh, a member, we are not trying to pull the member. Okay, we are trying to press the member from the both the ends, so it will try to crush, right? When you take um, a coke tin bottle, right, or a plastic bottle, when you try apply a pressure from the both the ends, at the center it will crumble, and the it will become shortened. The length of the column will reduce, that bottle will reduce. Same way in the columns, when you apply excessive loadings, it is above its maximum capacity, it goes above its maximum resistance, then it will crush. That load at where it crushes, that load is called as crushing load, right? That load is called as crushing load. Okay, next. And this crushing is seen in only short columns. Okay, the the failure occurs due to the crushing in the only short columns. Okay, in the long columns you will not see the failure, like failure as happens in the short columns, like crushing. The failure will not occur due to the crushing. Okay, we'll find out what type of failure occurs in the long columns, and which column is long column and which column is short column. How to identify it, we'll study in the next slide. Okay, now we'll find out what is buckling load. On a compressive member doesn't fail entirely by crushing. Okay, and as I said, all the columns are not short column, so all short columns will fail by crushing, not all the long columns will not fail by crushing. So the long columns will fail due to the bending. As the length increases due to the axial load, it will try to bend, right? The column will try to bend as because the length is more. Here in the crushing loads, uh, the length of the beam column is less, so there is no chance of bending, right? So there is a crushing happening. So when the length is more, the due to the loading, axial loading, the column will try to bend. So that bend is called as buckling. And when at the maximum loading, where the column will fail due to the bending, and it bends and it fails, that type of that loading is called as buckling load, or uh, that type of load is called bending load or buckling load. At the maximum load at which the uh, column will buckle, that is called as buckling load. All the long columns will fail due to the all the long columns will fail due to the buckling of columns, right? And all the short columns will fail due to the crushing. You have to remember this, it is very important. Okay, so what is safe load? The load under which the column does not buckle or crush. Okay, that is known as safe load. The load in which the load can resist, the load which can be resisted by the column, that is also called as safe load, right? Above that it can't resist and it fails, that is called failure load, right? It is called buckling load or a crushing load, depending upon what type of failure it is happening. Okay, so next, this is a formula for safe load. It is buckling load upon factor of safety. Okay, this is one thing, but this is buckling load, okay, divided by factor of safety. Factor of safety might be 3 to 4. Okay, it is 3 to 4. Now, what is Euler's equations? Euler is a famous mathematician. His full name is Leonard Euler. He has derived the equations to calculate the buckling loads. We have to find out the buckling load, right? What type, how much is the buckling load coming over the beams, how much we can put on the columns, how much loads we can apply over the columns. This is all I have to calculate. To that calculations, the Euler has found out the formula, right? And for that, to derive the formula, we know that for derivations we have to first assume some points. Depending upon that assumptions, we will derive the formula, right? So we will find out the um, first assumptions made by the Euler column theory. Okay, so these are the assumptions that column is initially perfectly straight, and after loading axially it will remain straight. Right, what we said is in the assumptions that the when we apply the load over the column it will remain straight, but actually in actual real case it doesn't happen like this. It will try to bend in its shape depending upon the loading. Right, that that deflection may not be visible, but there is some deformation or some buckling or some crushing happening at certain point that might not be visible to you. Okay, so this is for the first assumptions that we have made, that the column is initially perfect and before and after loading, right, and the cross section of the column will remain uniform throughout its length. Okay, what we assume that the cross section, okay, the length and the breadth will remain constant all along its length. That is the second assumptions we have made. Next is the column material is elastic, homogeneous, isotropic, and obeys Hooke's law. So what is meant by elastic? When we load it, when we load the column and we remove the load, it will come back to its original shape and size. Right? When you load, there is a deformations. When you remove the load, the deformations are zero. Okay, that is called elastic. Homogeneous, in one direction, of the material, the properties of the material remain same. That is what is called as homogeneous. And what is isotropic? In all the directions of the material, all the directions, the material quality will properties will remain same. Okay, means what? In all the directions, the property remains same. Okay, the properties of the material will be same in any point of the time, or any point on the material. Okay, that will be the properties will remain same. Next is the column will fail by buckling alone. Okay, and remember one thing, that this Euler equation is only useful for the wrong columns. This equation is not useful for the short columns. You can't calculate the short column values from this Euler equations. You can only calculate the loading from this Euler equation for only long columns. It is derived from only long columns. Okay, so we assume that the column only fails by buckling, but in the real case it might not be happening. It might be buckling, it might be failing due to the crushing, or it might be failing due to the both crushing and buckling. So this might be the case, but what we assume is that the column will fail only by buckling, or it is crippling load. So next is the self weight of the column is neglected. We will not consider the self weight of the columns in the calculations. Okay, we will not and we will neglect the self weight of the columns. Okay, so next is effective length. So what is that effective length now? As we know, effective span of the beam, it is the center of center distance between the supports, that is called effective span. Same way in the columns there is an effective length. Okay, this we can define it as the actual length of the column that is subjected to buckling. Okay, you can say the length of the column between the junctions of the beam. If there is a column in between the two junctions, at the top and the bottom, the point where the column and beams are meeting, that point is the distance between those 2 points is called as effective length. Okay, that is what is effective length. The length between the column that is subjected to buckling, that is length is called as effective length. So depending upon the type of support at different ends, that is the top end and the bottom end, the effective length will vary. Okay, the effective length will vary. This is very important, and you have to remember this effective length for different conditions. First condition is, you can see the first condition, that it is pinned type support. When the column is pinned at both the ends, then the length, effective length, will be remain same as L. Okay, remember this. When the column is pinned at both the ends or hinged at both the ends, means the effective length will remain L, same. If one end is hinged and one end is fixed, right, then your effective length will become L by root 2. Right, in this figure 2 you can see, right, it is one end is fixed and one end is hinged. So the effective length will be LE will be L by root 2. Right. Third is what? Both the ends are fixed. In the first case it was both the ends were hinged, right, and in the second case it was one end hinged and one end fixed, right. So in third case it is both the ends are fixed. So the effective length will be L by 2. The LE will be L by 2. Okay, it will be half the length of the column, effective length. And the last is one end fixed and one end is free. You can consider the example for the last is your electrical pole, right. The one end is fixed in the ground and another end, the top end, is free on the air. It has not been supported by any of the part, right, it is free. So that type is called as the fifth part, and it will be 2 times the L. Whatever be the length of the column is there, it will be the 2 times. The effective length will be 2 times. The length of the column is different and the effective length of the column is different. If they gave effective length, means you are given the effective length, directly use it. Okay, if they are not given, they are saying that that is a column length of the column, means you have to convert, you have to see the support conditions and you have to derive the, or you have to find out the effective length. That is very much important. You have to remember this, very important, very important. Without this you can't solve the problem, because the same effective lengths will be using in the formulas to, okay, will be substituting in the formulas to solve the problems. Okay, next, this is the Euler's formula. First we will try to write the Euler's formula, that is pi square, okay, pi square EI by L square. Okay, what it is? Pi square EI by L square. Okay, so what we are going to do is, this is length of the column, it is not effective length, it is length of the column. So we are going to substitute these values whenever the support condition is given into L. Understand what I am saying? Whatever the effective length you have got, that we are going to substitute here in this L, right. If it is L by root 2, then you are going to convert the L by root 2 here and put it the value here. Okay, you can do that. Calculate this first L. Okay, if they say one end is hinged and one end is fixed, calculate the L, that is effective length. Okay, that is L by root 2. Calculate the value and substitute in this formula, that is pi square EI by L square. Okay, pi square EI by L square. Remember this and only this. This will help you to solve any type of problems that is given to you. Okay, just remember the effective length and the Euler's loading formula. Okay. Okay, that is crippling load formula or buckling load formula, and this is uh, only for the long columns, right? It is only for the long columns. Next is one, two, or three types of the terms are there that you have to remember. Slenderness ratio. Slenderness ratio is defined as the ratio of effective length of the column to the least radius of gyration. Okay, so what is this least radiation of gyration? For the given section of the column, we will be having a radius of gyration. It is um, k is equal to root of I upon a. That is, I is the moment of inertia by the area of the column. That will give you the radius of gyration. That will be the least radius of gyration you have to take. Okay, when you divide the effective length by the least radius of gyration, you will get the slenderness ratio. Where this slenderness ratio will be helpful? Okay, as I said in the first slide, that there are classification of columns, right? Short column, medium column, and their long column. So how you are going to differentiate them? How you are going to find out whether the column is long column or short column or a medium column? So with help of this slenderness ratio, we'll be able to differentiate the columns. We have differentiated the columns. The first type is the short columns. If the slenderness ratio is less than 32, okay, if the value of this effective length in the least direction is less than 32, okay, then the column will be called as short column. Okay, medium column, the column which has a slenderness ratio, okay, is between 32 to 120. Okay, it has no units because it is a ratio. Okay, if the slenderness ratio is between 32 to 120, then it is called as medium column. And the long column, if the slenderness ratio is more than 120, slenderness ratio is more than 120, it is called as long column. Okay, remember this important point, right? So, and the Euler's equation will be applicable to valid for long columns. So we know the what is long column, what is short column. Okay, we'll be solving only the long column for long columns. Will not be having here any other formulas. We'll be solving for the Euler's equations, means only valid for the long columns. So we'll first try to find out the what is the problem. A round solid bar of 60 mm diameter and 2.5 meter long is used as strut. It might be a column or it might be a strut. They might give as strut or column. Don't worry, don't get panic. The steps will remain same. Nothing changes. Okay, nothing will change. One end is fixed and other end is hinged. So as per the given table and the diagram, it is what is effective length here? Effective length will be L by root 2. You can see the previous slides. Okay, it is given in your textbook also. Okay, you can go and check. Here it is also there. It is L by root 2. So what will be the this is what is first you have to find out. The length is given, the diameter of the round bar is given, and it is said the important point here is the support condition, that is one end is fixed and other end is hinged. Find the safe compressible load for this strut using Euler's formula. You have to calculate the load, that is crippling load is equal to pi square EI by L square. That is the formula you are going to use. Okay, so E is given, it is 2 into 10 raised to 5 Newton per mm square, and factor of safety is given. Okay, factor of safety is given. Okay, so whatever we are going to calculate through the Euler's formula, we will be getting the maximum load that is going to be applied over the column. The whatever load we are going to calculate, it will be the maximum load that the column or the strut of uh, 2.5 meter long and 60 mm diameter will take. We want the safe load that we are allowed to put, because we can't uh, put the maximum load, because if the load increases by certain degree also, then the strut will fail or the column will fail. So to keep some uh, safety factor, will be reducing the what the uh, working load. We'll be having some working load in which we are going to apply the loads. So to calculate that, you have to divide it by that maximum load by this factor of safety, which is given as 3. Okay, so first convert your meter dimension units into units. Okay, so then here in the formula you can see that it is EI, pi square EI is there, right? If you see the formula of the Euler's equation is pi square EI, right, upon L square. E is given, right? L is given, pi is constant, E is given, right? So what is not given? I is not given. So you have to calculate this I. What is I? It is moment of inertia. So for the round bars, what is the moment of inertia formula? This is also important. In the previous unit, that is your third unit, or the second unit, third and the second unit, you have used the moment of inertia, that is your bending stresses and geometrical stresses. You have found out what is the moment of inertia for the circle, rectangular, square, and for triangle, right? So what is the formula? It is I is equal to pi d power 4 by 64, pi d power 4 by 64. So the diameter is given, right? Substitute it and calculate the moment of inertia. Pi into 60 power 4 upon 64 you do, you will get the value as 636,173 mm power 4. Okay, now you have to calculate the effective length. As it is said, it is one end is fixed and other is hinged. So what will be the effective length? L by root 2. So what is the length? It is 2500 mm divided by root 2. You will get the value as effective length as 1767.77 mm. It is in mm. Sorry, it is in mm. Okay, because you are taken in mm, so the value also will be in mm. Now you got effective length. Other values are there. So substitute in the buckling load or the crippling load formula. P is equal to pi square into 2 into 10 raised to power 10 raised to 5. That is your E given here, right? 2 into 10 raised to power 5 Newton per mm square. So into the I value upon the effective length that you have calculated here, right? Then you will get a load, maximum load that is going to be applied, that you can apply over that column or a strut. It is 401,840.26 Newton. It is okay. So to it is what is asked in the question? It is the safe compressible load. I have given you the formula to calculate the safe loads. It is the whatever might be the buckling or the maximum load divided by factor of safety. You will get the safe load. That is whatever is the load divided by factor of safety. Factor of safety is given as 3. So divided by 3, you will get the safe compressible load over the column, right? Same type of problems will be there, just will be you will be asked to calculate the length, or load will be given and you will be asked to calculate the length. Sometimes you will be asked to calculate the I. L will be given, P will be given, you will be asked to calculate the I. Okay, same way you have to calculate the formulas, calculate the for various problems. this is what is about columns. Okay, thank you.